Hi, my name is Toby. In this video, we're going to be learning about solving equations graphically. So similar to the previous video, where we approximated solutions to equations that are pretty difficult or almost impossible to solve algebraically, we're going to be using graphs to solve these kinds of equations. So for this video, you're going to need to grab a calculator or even a graphing calculator, and if you don't have one, you can always pull up one online by using Algebra or Desmos. They have some great online graphing calculators. By the end of this lesson, you will be able to explain why the x-coordinates of the points where the graphs of the equations y equals f of x and y equals g of x intersect are the solutions of the equation f of x equals g of x. You'll be able to find approximate solutions to equations by graphing the functions with a graphing calculator. And you'll be able to figure out the number of solutions to a system of equations given the graph. All right, let's take a moment to convince ourselves this statement is true. So the statement goes, the x-coordinates of the points where the graphs of the equations y equals f of x and y equals g of x intersect are the solutions of the equations f of x equals g of x. So let's take a moment to dissect what this is telling us. So this tells us that if we have some function f of x, or some equation with two functions f of x equal to g of x, we can rewrite this as two functions where we set f of x equal to y and g of x equal to y. So let's go ahead and do that. So we have y equals f of x and y equals g of x. The statement tells us that if we graph these two functions and look at the intersection points, or the x-coordinates of the points where the graphs intersect, we'll have the solution to our original equation. Let's go through an example to convince ourselves that this really works. So let's say we have the following equation. We have 2x plus 1 is equal to negative x plus 4. So let's set these equal to y. So we're going to have y is equal to 2 of x plus, or 2 times x plus 1. And we're going to have y is equal to negative x plus 4. So let's go ahead and graph these. So to graph this first one, we can see there's an intercept point here of positive 1. So our intercept is here, and we're going up 2 over 1, up 2 over 1. So we can go ahead and draw that line. So this is kind of what our f of x looks like. Let's graph g of x here. So we have negative x plus 4. So our intercept point here is 4. So our intercept is here, and we have a slope of negative 1. So we're going down 1 over 1, down 1 over 1. Let's go ahead and draw a line through that. So something like this. And you can already kind of see where these points intersect. So the intersection point here, as you can see, is 1, 3. So the x-coordinate of this intersection point is 1. And remember, this is telling us that the x-coordinates of this intersection point, or all the intersection points, because sometimes there's more than one, these will be the solutions to the original equation. So this was our original equation right here. And let's go ahead and plug in 1 for x and see if this is true. So let's go ahead and do that. So we have 2 times 1 plus 1 is equal to negative 1 plus 4. So what we plugged in 1 for x, and let's go ahead and solve out. So we have 2 plus 1 is equal to negative 1 plus 4, and that's just 2 is equal, or sorry, 3 rather, is equal to 3. And that's true. So 1 is the actual solution to this equation. So let's go ahead and solve a more difficult equation using this technique. So we're given the following problem. Use a graphing calculator to find the solution of the following equation. Root x plus 3 is equal to x cubed minus 4. So we can say here that this is our f of x, and this is our g of x. And we can use a graphing calculator, or it tells us even to use a graphing calculator to graph this. And we're asked to round our answer to the nearest tenth. So the way we would graph this is we'd set one of our equations as y equals root x plus 3, and the other one as y equals x cubed minus 4. And wherever those graphs intersect, the x value of that intersection point, or the x values, since sometimes there's more than one, will be the solutions to this equation. So let's go ahead and graph this. So I'm going to pull up a graph right here. And if you don't have a graphing calculator, again, you can use an online tool, something like Desmos or GeoGebra. They have some great online graphing tools. Looking at this graph, the intersection point up here is pretty close is pretty close. So if we just draw a line going down from here, so this is pretty close to this point here. And what is that point? Well, each of these little lines is, this is 0.2, 0.4, 0.6, and this keeps going. And so this is going to be 1.2468. So x is, according to this, so roughly, so this is not exact, this is roughly 1.8, and we don't really actually even need to know what our y is. So that would tell us that the answer to this question is B. And that is in fact the correct answer. In this next problem, we are asked to use the graph to determine the number of solutions to f of x equals g of x. And over here, we've already been given the graph. And we're told this is f of x and this is g of x. And we don't even know exactly what these functions are, but that's not important because all we need to determine here is how many solutions this equation has. And the number of solutions to this equation is the number of times that the graphs intersect each other. Because for each of these intersections, we have an x-coordinate for this intersection that is another solution to this original equation. So the x-coordinate of these points, these are the solutions to this equation. And here we just have an intersection here and an intersection here. And that already tells us the answer to this question. The answer is 2 solutions. To wrap up this video, let's quickly go over what we've learned. So we learned that the x-coordinates of the points where the graphs of the equations y equals f of x and y equals g of x intersect are the solutions of the equation f of x equals g of x. We also learned how to find approximate solutions to equations by graphing the functions with a graphing calculator and then looking where those graphs intersect, or looking for the x-coordinates of where those graphs intersect. And lastly, we learned how to figure out the number of solutions to a system of equations given the graph.